Hey folks, welcome back to another video. Today we're looking at question 1214, sum of two BSTs. The way we'll be approaching this problem is by using recursion. So anytime you look at like a tree problem, there's a high probability that you'll be using recursion to solve the problem, and this is a similar case. So how do we solve this problem, right? We actually look at the current sum. So let's say like in sum would be equal to root 1 dot value plus root 2 dot value. Right, so if the sum is equal to the target, you just return true. If the sum, if it is greater than the target, you know that you need to decrement one of those values. So how can you do that? You can either do that by going to the left node on root 1, or you can do that by going to the left node on root 2. But how do you know which one to go to? You don't really know. So that's why you call this method recursively on root 1 dot left with root 2, and you call it also on root 1 with root 2 dot left. So thereby you're checking both the scenarios. If the sum is greater, you want to decrement the value, so you would do root 1 dot left, root 2, and target. If this doesn't work, you would call this again, but going to the left node on root 2. Let's fix that, and you clean this out. Awesome. So if this is the current sum is greater, but there's also another possibility, which is if the sum is less than. So if the sum is less than target, you need to get to a greater number, so you need to move to the right side of the tree. So instead of moving to the left, you experiment with both the right, and then you return it. And in the end, you just need to return false if you haven't seen anything. However, the one thing that we do want to do is we need to have a test condition, right? So we need to make sure that actually both of the roots have values in it. So only if root 1 is not equal to null and root 2 is not equal to null, then you would experiment with all of this stuff. So all of this goes into the if condition. Let me actually, okay, this looks cleaner. So if at this point you haven't returned anything, or if one of the values is null, you would just return false. Awesome. So let's try compiling this and see if this is okay. The first test case is okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the entire solution. The time complexity of the entire solution is of n being the number of total nodes in root 1 and root 2 trees. And the reason why is because there's a possibility that you have to go through all of the nodes till you actually find the target. And the space complexity is of 1, since we're not really using any additional space to store any of the data. However, there will be the call stack, but we won't really consider that for space complexity. Awesome. If you have any questions about the problems, please let me know in the comments below. Don't forget to subscribe to the channel, like the video. I would really appreciate that. It definitely motivates me to make more videos. Thanks so much, and I'll see you all in the next video.